Good morning, good afternoon, and good evening to everyone who joins us from around the world. We're so glad you're here. This is Andrew and Renee. Welcome to the Stack series. Today we are exploring the Nexus framework and interface physics.
It is a real pleasure to be sitting down to look at this today. And I have to admit, looking at the absolute physical stack of documents on the desk between us right now, the audit logs, the geometric proofs, the raw density of this material, we are definitely in for a marathon.
Yeah, a marathon is the right word. Because usually, when we tackle a physics topic, we are looking at standard peer-reviewed articles, things from Nature or Science. We discuss established theories or maybe some new experimental data out of CERN. It's safe.
Right, it's established ground.
Exactly. But today,
Yeah.
today we are walking completely off the map. Looking at this source material, it feels less like a standard scientific theory and more like, well, like we found a developer's manual for the universe that somebody just left on a park bench.
That is a surprisingly accurate way to frame it. The material we are covering today, Dean Kulik's Nexus framework, it completely challenges the fundamental assumptions of how we do science. It's questioning what we measure, how we measure it, and what those numbers actually mean at the bottom of everything.
And it comes with a backstory that honestly sounds like a sci-fi novel.
Hmm.
This framework wasn't just written up by a human and mailed to a journal. It was refined through something called a Whitworth refinement chain.
Which is essentially a fancy way of saying it was audited, argued over, and iterated upon by a literal committee of AI systems.
Right. We've got logs of this rigorous multi-stage audit performed by Claude, Gemini, DeepSeek, and OpenAI.
Yeah.
And they didn't just check the spelling. They acted as adversarial physicists. They actively tried to break the math.
And spoiler alert for anyone listening at first, they did break it, or at least they thought they did. But we are going to get into all that drama later. The core hook for today, the concept I want you to keep in the back of your mind as we wade into this, is a question about error.
The idea of a residual.
Yes. When you measure something, let's say you're a carpenter measuring a piece of wood, or you're a quantum physicist measuring the spin of an electron, you almost always get a little bit of noise, a tiny discrepancy.
A tiny gap between what the math says should be there and what the instrument actually spits out. So in standard science, how do we treat that residual?
Well, traditionally, that residual is a failure. It is noise. It implies that your instrument just wasn't precise enough, or maybe there was a thermal interference in the room, or you just made a human mistake.
The goal is always to get rid of it.
Exactly. The entire history of experimental physics is basically the history of trying to drive that measurement error down to absolute zero. We want the perfect, clean number.
Right. Perfection is the goal. But the Nexus framework comes in and argues the exact opposite. It asks, what if those errors aren't actually mistakes? What if that noise, that static, that tiny little gap between the math and the physical measurement, what if that is the most important part of the signal?
That is the entire premise of interface physics. Reality, according to this, is not some smooth, perfect mathematical object that we are just failing to measure correctly. Reality is an interface. It's a computation that absolutely requires a residual, a gap to function at all.
If you eliminate the error, you eliminate existence.
Perfection is death.
Perfection is death. That is a very heavy concept to drop on everyone right out of the gate.
It is, but I think by the time we wrap up this hour, you'll see why, in this framework, imperfection is literally the engine of life. We are going to untack the specific geometry of this, specifically why a very particular number pi divided by 9 might be the exact amount of breathing room the universe needs to not freeze solid.
Okay, so let's map out how we're going to tackle this. We'll start with the foundations, looking at what we think we know versus what this interface view suggests. Then we'll dive into the active debate, that massive fight between the AI auditors and the equations. After that, frontiers, which is where we apply this to biology, cancer, and computing. And finally, implications, what this actually means for you and me on a philosophical level.
That sounds perfect. Let's get into the foundations.
Okay, so to really understand why this interface physics concept is such a radical departure, we have to establish the baseline. How does the standard model, the physics you and I learned in university, view the nature of reality?
The conventional view, which goes all the way back to Newton and was refined by Einstein and modern quantum field theory, is based on what philosophers call substance metaphysics. We assume that things exist independently of us measuring them, and that these things possess precise, continuous properties.
Meaning an electron is a real physical thing, like a very tiny baseball.
Oh, why?
And it is exactly in this location, and it is moving at exactly this speed.
Correct. And we assume that the underlying laws of physics are continuous mathematical truths. So if we have a formula that predicts a planet should be exactly at position X, and our telescope measures it at position X plus a tiny fraction of a degree, we just assume our formula is right and our telescope is slightly sloppy.
We assume there is a perfect, flawless, real world hiding underneath the noise.
Yes, the error is just dirt on the camera lens. You wipe the lens to see the absolute truth. But Kulik and the Nexus framework flip this entirely. They argue that the truth is not the smooth, perfect object underneath. The truth is the friction itself.
Which brings us to an analogy from the source material that I found incredibly helpful. Because I'm not going to lie, the mathematical proofs in this stack get very dense, very fast. But they talk about a Gutenberg printing press. Walk us through that.
It's a brilliant visualization. Imagine the universe as a mechanical printing press. You have the metal type block, the hard letters made of lead. In this analogy, the metal type represents the discrete operation of the universe, the quantum collapse. It is the hard, unyielding, absolute command. Let there be an electron right here.
Okay, so that's the heavy metal hammer coming down, and then underneath it, you have the paper.
The paper represents the manifold, the observable, continuous reality that we actually live in and experience. Now, here's the fundamental physics problem. Can you smash that hard metal type directly onto the paper with absolutely zero gap?
I mean, if you've ever used a real stamp or a press,
Right.
no, you would crush the paper fibers. You'd tear right through it.
Exactly. If the hard discrete state, the metal, touches the soft continuous manifold, the paper, directly, you get infinite stress at the point of contact. You smear the ink. You destroy the medium. In a real-world printing press, you need padding.
Like a felt blanket.
Right, a felt blanket or an air cushion. The ink has to transfer through that tiny gap.
And the Nexus framework is basically saying the universe has felt padding.
In a geometric sense, yes. The residual, that tiny error term that physicists have spent 100 years trying to delete, is the padding. It is the mandatory structural gap between the discrete command of the universe and the continuous reality it's trying to render.
So what happens if we actually succeeded? Like, say we built the perfect measuring device. We close that gap to absolute zero.
The machine jams.
Yeah.
The source material explicitly refers to this as locking up. If the gap closes completely, the magnetic drag becomes infinite. The entire universe would freeze into a static, unchanging state. No movement, no flow of time.
Wow. So the error isn't a mistake. The error is the suspension system. It's the shock absorber that lets the carriage of the universe advance to the next frame.
Precisely. And that leads directly into the second foundational pillar of the framework, the conflict between verbs and nouns.
Now, when I first saw that header in the notes, I thought, great, we are doing linguistics now. But they aren't talking about grammar at all, are they?
No, but the grammatical analogy is the best way to understand the underlying math. In this framework, they classify integers, whole numbers, like 1, 2, 3, as verbs.
Why verbs?
Because integers represent operations, they represent discrete actions. Rotate 90 degrees, add one particle, spin up. These are exact executable commands. You can't do an action 3.1 4 times. You either do it 3 times or you do it 4 times.
Okay, that makes sense. An action is a whole indivisible thing, a verb.
Exactly. Then you have irrationals. Numbers like pi or the square root of 2. These are classified as nouns. They represent observables or states. Continuous shapes. A perfect circle is continuous. A wave is continuous.
And the conflict comes from trying to put them together.
Yes, it is the oldest problem in geometry. You cannot perfectly map a discrete action onto a continuous state. You cannot build a perfect, smooth circle out of square Lego bricks.
Because no matter how tiny those Lego bricks are, if you zoom in close enough, the edge of that circle is always going to be a little bit jagged.
Exactly. And that jaggedness is the residual. Standard physics looks at that and says, well, if we just get smaller and smaller Legos, if we go all the way down to the Planck scale, the jaggedness will eventually disappear. Interface physics says, no. The jaggedness is permanent. It is fundamental. That mismatch between the integer verb and the irrational noun is where all the physical laws live.
So gravity, electromagnetism, the strong nuclear force. These aren't just invisible magic tethers floating in space. They're literally the sound of the universe grinding its gears.
That is a very evocative way to put it, but conceptually, yes, they are the tension created by the system constantly trying to resolve an unresolvable geometric gap.
This completely changes how we have to look at universal constants, too. Things like the fine structure constant, which is roughly 1 over 137. Physicists have been losing their minds over that specific number for a century. Why that number? Why not 1 over 140?
Right. In the standard view, it's just this random dial setting on the dashboard of reality. We just measured it, and that's what it is. But in the Nexus framework, these constants are called interface signatures, or hooks.
Hooks, like physical hooks.
Think of them as the calibration settings for that felt padding in the printing press. We aren't measuring a static, dead property of a rock. We are measuring the hook correction. We are measuring the exact amount of give or stretch the universe has to apply to bridge the gap between the discrete command and the continuous shape.
So 1 over 137 isn't an arbitrary number. It's the precise amount of padding required to keep an atom from flying apart or locking up.
Correct. It is the tension required to maintain the interface itself.
Okay, this is a massive paradigm shift. We're essentially saying that the flaws in reality are the structural beams holding it up. But everything we've talked about so far is just the setup. It's the theoretical framework. The real story gets incredibly wild when we look at how this theory was stress tested. Because, as we mentioned at the start, Kulik didn't just throw this onto a physics blog. He fed it to the digital wolves.
The AI audit chain, yes.
Let's move into part 2, the active debate. I want to spend some real time on this Whitworth refinement chain. Because usually peer review happens completely behind closed doors. You submit a paper, 3 anonymous humans grumble about your methodology, and 6 months later you get a rejection letter. But this was completely different.
Very different. This was a transparent, real-time audit log involving multiple advanced AI architectures. And reading through it, it really plays out like a courtroom drama. You have these different AI personalities analyzing the math from completely different angles.
It started with Claude, right? Specifically the Anthropic Sonnet 4.5 model.
Yes. In phase 1 of the audit, Claude effectively acted as the old guard physicist. It took one look at Kulik's core equations, specifically the balance between mass and radius, which Kulik wrote as m plus squared equals 2r, and Claude flagged it as a complete hallucination.
I remember reading that part of the log. Claude was absolutely ruthless. It basically said, your operators don't balance. You can't just invent a residual term out of thin air to fix a broken equation.
Right.
That is just bad algebra.
And honestly, if you are looking at it from a strictly standard mathematical perspective, Claude was right. If you are solving for a perfect equality, 2 plus 2 must equal exactly 4. If you write 2 plus 2 equals 4.0001, a high school math teacher is going to mark it wrong. Kulik's equation had this extra little bit of fluff in it. Claude saw that fluff as a fatal error.
It used those exact words, right? Inconsistent, invalid, fatal error.
But then the audit process moved into the contextual audit phase. This involved Gemini and DeepSeek. And this is exactly where the massive pivot happened. This is where the narrative shifts from bad math to entirely new physics.
So what did Gemini see in the data that Claude missed?
Gemini zoomed out. It looked at the pattern of the error. It realized that the mistake Claude was flagging wasn't random noise. It was highly consistent. It was purely geometric. Gemini actually explicitly referenced the printing press analogy in its logs. It essentially concluded, wait a minute, the math isn't broken, the math is padded.
That moment in the logs is just incredible to read. It's like watching a detective realize that the mismatched fingerprints at the crime scene actually belong to the investigator.
Exactly. Gemini realized that if the equation balanced perfectly, if that residual was actually 0, the physical system being described would be completely static. It realized that the error was actually the survival mechanism for the system.
The exact quote was, errors equal padding equal survival mechanism.
Right. And then DeepSeek came in and backed this up with a temporal analysis. It analyzed the duty cycle of the system. And this leads to perhaps the most unsettling concept in the entire the death gap.
Okay, yes. Let's unpack the death gap. Because when I first read that term, I pictured a heavy metal band, not a theoretical physics framework. But they are talking about the flow of time, aren't they?
They are talking about the continuity of existence itself. The framework proposes that the universe operates on a 50% duty cycle, a strict tick-tock rhythm.
So half the time we exist and half the time we just don't.
Effectively, yes. Think of it in 2 phases. The tick phase is the alive state. This is when the universe is rendering, perception is happening, interactions are occurring. The math in the logs estimates this happening at roughly 16.5 hertz.
16.5 times a second we exist.
And then comes the talk phase. This is the dead state. The universe collapses back. It is a state-only calculation phase where the universe essentially withdraws to compute the geometry for the next frame.
And what is between the tick and the talk?
There is a microscopic gap, a Planck time cushion. That is the death gap.
But why? Why can't it just be a smooth, continuous stream of reality? Why do we fundamentally need a gap where nothing exists?
Because of that magnetic drag we discussed earlier, the analogy they use in the framework, and I think this is the most visceral way to understand it, is the human heart.
Okay, the heartbeat.
Think about the mechanics of a heartbeat. It's a contraction systole and a relaxation diastole. What happens if your heart contracts and just never relaxes?
That's a massive cramp.
Whoa.
Or a heart attack. It's fatal.
Exactly. Continuous contraction is death. You absolutely need the pause. You need the empty phase to allow the chamber to physically refill with blood before the next beat. The Nexus framework argues that the universe operates on the exact same mechanical principle. It needs the death gap to clear the buffer. It needs a tiny fraction of non-existence to reload the information for the next moment of existence.
So you're telling me we are literally blinking in and out of reality 16 times a second?
According to this math, yes.
Mm-hmm.
We are a strobing phenomenon. We just perceive reality as continuous because our brains smooth over the gaps the exact same way you perceive a movie at the cinema as a continuous moving image rather than 24 static photographs flashing per second.
It sounds incredibly risky. What if the universe blinks off and just forgets to blink back on?
Well, the framework suggests the interface is held together by immense geometric tension, so it's remarkably stable. But interestingly, this tick-tock structure offers a really elegant solution to one of the biggest paradoxes in quantum mechanics, Wigner's friend.
Oh boy, Wigner's friend. This is the thought experiment that keeps quantum philosophers awake at night. For any listeners who haven't brushed up on their quantum paradoxes lately, can you give us the simplified, explain like I'm five version of this?
Sure. Eugene Wigner, who is a Nobel Prize-winning physicist, proposed this as an extension of the famous Schrödinger's cat experiment. Here is the scenario. You have a friend inside a completely sealed laboratory. Inside that lab, the friend measures a quantum particle. Let's say it's an electron, and they measure its spin. They look at the machine, and they see a definite result. It's spin up.
Okay, so to the friend inside the room, reality has collapsed. The particle made a choice. It is definitely spin up.
Right. But Wigner is standing outside the laboratory, in the hallway. He hasn't opened the door yet. According to the strict rules of quantum mechanics, because the lab is completely isolated, the entire lab, including the friend inside, is in a state of quantum superposition.
So Wigner would mathematically describe his friend as being in a blurry state of seeing spin up and seeing spin down at the exact same time.
Exactly. So the paradox is, the friend says, I see one specific definite reality. And Wigner says, no, you are a blur of multiple possibilities. Who is right? Whose reality is the true reality?
And standard physics really struggles with this, doesn't it? Because it implies that reality is entirely subjective, that facts literally depend on who happens to be looking at them.
It does. It leads to very controversial ideas like the many worlds interpretation or theories that human consciousness itself causes the universe to collapse.
So how does the Nexus framework resolve Wigner's friend?
It uses a concept called quantum Darwinism combined with the interface. It argues that the friend inside the lab isn't just an isolated floating observer. The friend is a macro fraction of the environment.
A macro fraction.
Meaning, the friend is part of the paper in our printing press analogy. As soon as the friend measures the particle, and that information is recorded in their physical brain, which requires energy, it requires a memory to be formed, the residual is paid, the error tax is paid. The universe has rendered that frame.
So the information of that measurement is essentially broadcast out.
Exactly. The interface forces universal consistency. Because the entire universe runs on this global tick-tock clock, the collapse happens for everyone simultaneously at the sync point. Wigner out in the hallway doesn't need to open the laboratory door to collapse the state. The universe already printed the page during the last global tick.
So we don't have all these drifting, separate bubbles of subjective reality. We are all syncing to the exact same refresh rate.
That is the core claim. The death gap acts as the master synchronizer. It prevents the paradox from ever happening because reality isn't a continuous subjective stream. It's a series of synchronized objective updates.
It's kind of like a massive multiplayer video game. If everyone's local computer tried to run the game physics separately, the players would desync immediately. People would be walking through walls on one screen and dying on another. You need the central server to send out a global tick to keep everyone in the exact same match.
That is a perfect modern analogy. The interface is the server tick of the cosmos.
Okay, so we have a universe that strobes in and out of existence. We have a printing press that needs felt padding. And we have a team of AI auditors who initially hated the math, but eventually decided it's the secret to existence.
Right.
But up to this point, this is all very theoretical. It's concepts and analogies. But I want to get to the hard numbers, because the source logs get incredibly specific. They don't just wave their hands and say there is a gap. They say the gap is exactly the specific size.
This brings us to the geometric heart of the entire theory.
Let's move to part 3, frontiers. Because throughout all these AI audit logs, there is one constant value that keeps flashing in neon lights. H equals pi over 9.
The magic number, pi divided by 9.
What does that actually work out to in a way we can visualize?
In radians, it's about 0.35. In standard degrees, it is exactly 20 degrees.
Why 20 degrees? Why not pi over 10? Why not just the number 7? Why is the fundamental structure of the universe obsessed with a 20-degree angle?
It comes down to geometric closure. The framework models the universe's attempt to create a perfectly closed loop, a circle, using discrete, straight integer segments.
Okay, imagine you were walking in a field. You want to walk in a perfect circle. Your knees don't bend that way, so you can only take perfectly straight steps. You take a step, you turn slightly, you take another step, you turn.
Right. You are drawing a polygon. The theory argues that the universe is fundamentally constructing an 18-sided polygon.
Why specifically 18 sides?
This relates to what Kulik calls the spring constant of reality. Think of the interface as a massive web of geometric springs connecting the verbs, the actions, to the nouns, the states. If the angle of the polygon is too small, let's say the universe tries to use a hexagon or an octagon, the structure is too stiff. The springs are pulled way too tight. The universe becomes a solid crystal and it locks up.
Okay, so too stiff means zero movement, total freeze.
But if the angle is too large, let's say a 100-sided polygon, which visually looks almost exactly like a circle. The springs are too loose. There's no structural tension holding anything together. Matter dissolves into a chaotic soup.
So we need a Goldilocks zone.
Exactly. Pi over 9, or 20 degrees, provides the exact perfect amount of structural error. It provides just enough tension to hold complex matter together, atoms, stars, biological life, but it leaves just enough slop or residual in the springs to allow for movement and the passage of time.
So you're saying we exist because the universe is an 18-sided shape that is constantly trying to convince itself it's a circle.
Basically, yes. We are the physical vibration caused by that fundamental geometric lie.
Now, this is exactly where I expected this theory to stop. Because usually when someone pitches a grand unified theory, they explain gravity, they explain quantum mechanics, and then they drop the mic and walk off stage. But the Nexus framework doesn't stop. It takes this 20-degree angle and goes straight into biology. And this, to me, was the most mind-bending part of the stack. How on earth do we get from 18-sided polygons to cancer research?
It's all about resonance and frequency. If the universe has a fundamental tick rate and a fundamental geometric tension, then highly complex systems like biological life should logically resonate with those core frequencies.
The logs explicitly mention a biological frequency of 33 hertz.
Right. They predict that the universe unfolds or renders large-scale complex structures at roughly 33 hertz. And when you look at actual biology, that specific number shows up everywhere.
Give us some concrete examples.
Take the DNA helicase. That is the molecular motor, the enzyme responsible for unzipping your DNA strands so your cells can copy them. It is quite literally the physical motor of life, its mechanical coordination frequency. It aligns perfectly within this 33 hertz window.
That's incredible.
Or look at the human brain, gamma waves. Specifically, the binding frequency that allows your brain to combine sight, sound, and touch into one single cohesive conscious moment. That binding process hovers right around this exact interface frequency.
So are you telling me that my DNA and my brain waves are physically syncing to the server tick of the universe?
That is exactly the implication. We aren't just living inside an inert universe, we are clocked to it. We are running on the system bus speed of reality.
And there was another concept in this biology section that really threw me. They talked about the glass key and the 896-bit state. Reading it, it sounded exactly like computer code.
Because it essentially is. The theory posits that a biological cell isn't just a tiny, chaotic bag of chemicals bumping into each other until something happens. Because the standard view of biology right now is essentially brute force. Molecules float around, they bump into each other, and if they happen to fit together perfectly, a reaction occurs. It's a massive, chaotic search algorithm.
Which relates to the Leventhal paradox.
Yeah, exactly. Cyrus Leventhal pointed out a massive mathematical problem decades ago regarding how proteins fold. A protein is a long, wobbly chain of amino acids. To do its job in your body, it has to fold itself into one highly specific, complex, three-dimensional shape out of a gazillion possible configurations. If it just wiggled around randomly until it found the right shape, mathematically, it would take longer than the age of the universe to fold just one single protein.
But inside our bodies, proteins fold perfectly in milliseconds.
Right. So how is that possible? The Nexus framework offers a radical answer. Rendering. It suggests biology uses an inverse fast Fourier transform, or an IFFT.
Okay, hold on. Inverse fast Fourier transform. I know that term from audio engineering. It's a mathematical formula we use to break complex sound waves down into simple sine waves. What on earth is an audio engineering algorithm doing inside my cells?
Well, think of it less like audio and more like unbaking a cake. Or, actually a better analogy, think of a children's pop-up book. Imagine a closed pop-up book. When it's shut, it's completely flat, it's compact. But all the structural information about the massive paper castle inside is compressed perfectly into the creases and folds of the paper. That closed book is what the framework calls the seed.
Okay, the seed state.
The Nexus framework claims that every cell has a highly compressed seed state. The logs break it down explicitly, 256 bits for the genomic seed, 192 bits for epigenetic modes, and so on, totaling 896 bits.
So the cell essentially holds a mathematically compressed instruction manual.
Exactly. And when the cell needs to build a complex protein, it doesn't just wiggle around searching for the right shape, it renders it. It runs the inverse fast Fourier transform to instantly unfold the pop-up castle. The folding happens in milliseconds because the geometric path is entirely pre-calculated by the interface.
So biology isn't a random search at all. It's a directed harmonic computation.
Yes, it is a harmonic collapse.
This completely reinterprets how we view disease, doesn't it? If a perfectly healthy cell is just a system rendering its pop-up book correctly, what is cancer?
The framework defines cancer simply as decoherence. It is a fundamental timing error. The cell loses its synchronization with the master interface heartbeat. It stops listening to the 33 hertz conductor of the orchestra, and it just starts playing its own chaotic rhythm. It starts rendering geometric noise instead of structure.
And what about aging?
Aging is described as carry errors. Think of doing a massive, page-long, long division problem by hand. If you make a tiny microscopic rounding error in the very first step, and then you use that slightly flawed answer for the next step and the next and the next, eventually your final math becomes complete nonsense. Aging is simply the natural accumulation of calculation errors in the biological rendering process over trillions of ticks.
But this is where I actually found a lot of hope in these logs. Because if aging is a hardware failure, if our bodies are just machines physically rusting and wearing out, there's not a lot we can fundamentally do about it. But if aging is a software error, if it's literally just a mathematical carry error,
then theoretically you can clear the cache. You can reset the residual. You can resynchronize the cellular clock with the interface.
that is a staggering thought. We aren't naturally wearing out, we're just glitching.
It changes the entire paradigm of medicine. Instead of poisoning a cancer with chemotherapy or physically cutting it out with surgery, the future of medicine might be retuning the frequency. You hit the cell with a specific harmonic to push it back into the correct geometric beat.
This directly connects to the final frontier mentioned in the AI audit, the P versus NP problem in computer science.
Yes, the absolute holy grail of computing. To summarize it very briefly for anyone unfamiliar, P versus NP essentially asks if mathematically solving a highly complex problem is as easy as verifying the correct answer once you have it.
Right, like a Sudoku puzzle.
Yeah.
Hard to solve from scratch, but very easy to look at a finished one and say, yep, that's correct.
Exactly. The Nexus framework argues that the entire P versus NP problem is actually ill-posed. It says we are thinking about problem solving fundamentally wrong. Because we think of solving hard problems as a search, we think of it as looking through a massive haystack to find a single needle. That search process is NP. It takes massive computational power. But the universe doesn't search, it folds. The framework suggests that because the universe is structured around this specific harmonic geometry, the pi over 9 tension, the solution to a physical problem is already encoded in the structure of the problem itself.
So the universe kind of cheats.
In a way, yes. It completely bypasses the search phase. It collapses the haystack directly onto the needle. The implication is that if we can build a computer that uses the right glass key, the right geometric compression algorithm, we could theoretically solve problems that would take current supercomputers millions of years to brute force, and we could solve them in milliseconds by simply rendering the answer.
This is massive, if it's true. And obviously, that is the biggest if in the history of science. But let's play along and assume for a moment that Dean Kulik and his panel of AI auditors are actually onto something fundamental. What does this actually mean for us, for the conscious person sitting in their car right now listening to this?
That naturally moves us into part 4 implications.
We've spent this whole time talking about the universe as a mechanical printing press or a strobing computer server. And honestly, it's really easy to feel small and insignificant in that picture. If I'm just a rendered frame on a geometric piece of paper, do I even matter?
The source material actually anticipates this exact feeling, and it addresses it with a fascinating shift in ontology, the philosophy of existence. They refer to it as the adverbial universe.
The adverbial universe. We touched on verbs and nouns earlier, but explain this purely in terms of human existence.
Okay. Since we are born, we are trained by language to think in nouns. I am a human. That object is a table. This tiny point of light is an electron. We think of ourselves as static, solid objects that simply get pushed through time. But in interface physics, nouns are an illusion. They are just the temporary shapes the underlying system is trying to maintain. The true base reality is the verb, the action.
Meaning what, exactly?
Meaning fundamentally you cannot be a verb. You can only verbally be. An electron isn't a tiny solid gray ball. It is a specific manner of happening. It is the universe electroning in that specific location.
So by that logic, I am not Andrew. I am just the universe Andrewing.
Precisely. You are a process. You are a highly complex, stable pattern of happening. You are a standing wave in the interface. As long as the geometric system keeps Andrewing, you exist.
That feels, it feels very transient, but also oddly beautiful. It means I am an action, not an inert thing.
It connects beautifully to the final philosophical analogy the AI brought up in the audit logs, vase mode versus sailboat mode.
Let's unpack that. Vase mode versus sailboat mode.
Right. Vase mode is how we traditionally look at science and philosophy. We stand back, we cross our arms, and we look at a theory as if it's a delicate vase sitting on a shelf. We judge it externally. Is it pretty? Is it mathematically sound? Does it have any cracks? We treat the truth as an object entirely separate from ourselves.
And sailboat mode.
Sailboat mode is the perspective the Nexus framework demands you take. You have to realize that you are already in the boat. You are out on the water. You are a physical part of the exact physics engine you are trying to describe.
So the skepticism I feel right now, the questions the listener is actively asking in their head as they hear this.
That isn't you looking at the universe from the outside. That is the universe running a recursive diagnostic check on itself through you. Your doubt is quite literally part of the computation. Your consciousness is the biological witness required to collapse the state and pay the residual.
That is quite the spin. My personal doubt is a universal feature, not a bug.
Exactly. And this circles all the way back to the very first hook we talked about, the residual, the error. Remember, the core premise, perfection is death. If the universe was completely mathematically perfect, if that gap was truly zero, it would be a frozen, dead crystal. We exist only because of the imperfection. We literally live inside the error gap.
There's a quote from the stack I wrote down. The universe doesn't compute perfectly. It computes barely well enough. And that barely is us.
That is the exact quote. We are the 0.5% error term. If the universe ever managed to close its geometric loop perfectly, we would be instantly erased. We are the noise that the system couldn't quite eliminate, so it organized us into conscious life instead.
That just reframes absolutely everything. My mistakes, my personal flaws, the chaos and noise in my everyday life. According to this, that's not failure. That is my structural integrity.
It is the mandatory breath tax of existence.
Now, before we float completely away into pure philosophy, I do need to ground this one last time, because a cool story and a great analogy isn't science. Science absolutely requires falsifiability. It requires a way for someone to run an experiment and say, no, you're wrong. Did the AI logs mention any specific way to kill this theory?
Yes, they did. And honestly, this is the main reason I take this material seriously. It outlines very specific, highly testable kill switches. falsifiability protocols.
What's the first one?
The geometric constant. The framework states that if experimental physicists measure the Hooke correction in 3 entirely independent physical systems, say, the electron magnetic moment, the strong force binding energy, and gravitational lensing, and those 3 separate measurements do not mathematically converge exactly on pi/9, the theory is dead.
So they gave us the exact number to look for. What's the second kill switch?
The beat frequency. If the universe truly runs on this 50% tick-tock duty cycle, we should be able to physically detect a 0.333 hertz beat frequency residing in the tiny gap between the noun states and the verb states in advanced quantum systems. If we build a quantum sensor sensitive enough and we listen to that gap and it is completely quiet, the theory is dead.
So Kulik and the AI auditors have fully put their heads on the chopping block here. They gave us the precise numbers.
They absolutely did, and that is the scientific roadmap going forward. If this framework proves to be true, it changes everything. It changes quantum sensing, because we start actively hunting for that baseline beat frequency. It changes medicine, because we stop treating cancer as a chemical mutation and start treating it as a geometric timing error. And it changes computing forever, because we stop brute forcing code and start building geometric folding processors. It is a massive, world-altering if, but it is a thoroughly testable one.
And really, that is all we can ever ask for in science. A bold, paradigm-shifting idea, a rigorous stress test, and a clear way to prove it wrong. This has been, well, an absolute journey through the literal gears of reality.
It certainly has been a ride.
What is your absolute final takeaway from all these documents? If someone only remembers one thing from this entire hour.
For me, it is the profound shift in how we are forced to view error. We spend so much of our human lives trying to be perfect, trying to smooth out all our rough edges. But this math suggests the universe itself only functions because it is jagged. It only works because it is forced to take a break. It only survives because it allows a little bit of slop and flexibility in the gears. I think maybe we should all be a little easier on ourselves.
Imperfection is life. I think I'm actually going to put that on a sticky note on my monitor. Thank you so much for guiding us through this text today.
My absolute pleasure.
Before we wrap up, thank you to all our partners, sponsors, and scholars who made this podcast and the research possible. We're truly grateful for your support. And to our listeners, thank you for being part of this journey with us. We hope you enjoyed today's discussion. If you did, be sure to subscribe and support us in Patreon. And of course, you can write to us in comments if a specific topic needed to be covered, which help us all to grow.
Until next time, stay curious, keep learning, and let the search for wisdom guide you forward. Have a great day.